I think we should start out with a little warm up on how we do these. Remember, with inverse functions, you have to pass the horizontal line test. And we notice that every single one of our trig functions don't pass the horizontal line test. For example, sine goes on and on forever. And if I do the horizontal line test on sine, it's not going to pass. So the way we kind of cheated to make this function actually do have an inverse is we did this thing called restricting the domain, which just meant kind of cutting off the function at from the left and from the right so that it does pass the horizontal line test. And well, because of this, the answers for sine has to be between quadrants 1 and quadrants 4. Okay, now we actually haven't finished all this inverse sine problems here. So I think what I'm going to do in the very beginning is maybe go through another inverse sine problem with you, just so we get in the hang of things of figuring out what sine, inverse sine questions are supposed to look like. And then we can kind of move on to the tangent ones and figure out how to do these. Okay, so in example 5, we wanted to find the inverse sine of -1/2, right? Now, step 1 of doing these questions is, well, rewriting the question in terms of, well, how we think of it, right? So if we're trying to find what the inverse sine is, what we're actually doing is asking ourselves, the sine of what angle equals -1/2, right? That's what we're being asked here, okay? Now, step 2 is to have you look at your unit circle. Is sine the x value or the y value on the unit circle? The y value, right? So you're just going to take a look at your unit circle and look for every single angle where the y value is -1/2. Which angles are those? Does anyone need a unit circle? Good, 7 pi over 6 and 11 pi over 6, right? Those are the two angles where the y value is -1/2. And so these two angles actually do answer that question. Now, the problem with inverse functions is that there's always going to be one answer. So we have to eliminate one, okay, which brings us to step 3. Which quadrants can inverse sine be in? So we're looking for which two quadrants we're looking at? 1 or 4, right? So sine can only be in quadrants 1 or quadrants 4. Which one of the two angles is in either quadrant 1 or 4? Yeah, 11 pi over 6 is in quadrant 4. So we're going to eliminate 7 pi over 6 and just take 11 pi over 6. All right, moving on to step 4. Now, our answer is 11 pi over 6, but the traditional way of doing this is our answer has to be between -pi/2 and +pi/2. Now, 11 pi over 6 is more like, I don't know, 1 point something pi. It's not between -0.5 pi and 0.5 pi. So we have to make it in between those two angles. And I think if you remember, in order to do that, we either add or subtract 2 pi to find a coterminal angle. In this case, subtracting 2 pi is probably the way to go because, well, 11 pi over 6 is too big, right? Okay, finding a coterminal angle. I'm going to subtract, oh gosh, something over 6. What is 2 pi over 6? Or 2 pi is an angle over 6?
12 pi.
12 pi, perfect. And then when you subtract this off, we get -pi over 6. And that is the final answer. All right. Any questions on this example? All right. Now we got 2 more sine ones that we haven't done yet. Do you want to go through those together, or do you, if I gave you the answer, would you be comfortable doing those on your own? You know what? How about this? I'm just going to give you the answers for example 7 and 8. Okay, I think I walked around the classroom. I saw everyone on the right track. Example 7 for the sine question should be pi over 4. Okay, and example 8 for the sine question should be pi over 2. Okay, I think when I walked around, everyone got that one right. But if you have any questions, just ask me after class or come to my office hours. And I think we did enough sine problems. Okay. After we worked with sine, we talked about cosine, which was pretty much the same thing, except for instead of quadrants 1 and 4, our answers had to be between quadrants 1 and 2, which actually made cosine a little bit easier to work with. But we did a lot of practice with cosine on Monday. And then we finally started to talk about tangent, right? So we talked about the tangent function. It didn't pass the horizontal line test at first, but we restricted the domain to make it actually do have an inverse. But because of that, tangent's kind of like sine. The answers have to be between quadrants 1 and quadrants 4. Same thing as sine. Okay. Now, tangent is not as easy as just taking a look at your unit circle and figuring out what the y value is and what the x value is. Tangent takes a little bit of work to figure out what the values of tangent are. And this is where memorizing this chart becomes really, really important because it helps us easily be able to go from inverse tangent to the angle. Okay, now we went through this chart. These are things that you have to know. These are all the tangent values in the first quadrant. And I'm going to kind of give you a little hint on how to do these questions. So for inverse tan, first you're going to do the same thing with all the questions, rephrase the question so it's easy to think about. Next, what you're going to do is you're going to use the tangent chart, and that's going to tell you what the denominator of your angle is going to be. Okay, and I know that sounds weird at first, but I promise it'll make sense in an example. Step 3, you're going to make sure it's between or in quadrants 1 and 4. And in step 4, you're going to really ask yourself, okay, is that angle really between negative pi over 2 and positive pi over 2? If not, you might have to subtract or add 2 pi. Okay, let's do some examples here. Let's say I wanted to find the inverse tangent of negative square root of 3. Okay, well, step 1 is easy. We've done it a lot of times. If I want to figure out what this angle is, I'm really asking myself, what angle do I take the tangent of to get negative square root of 3, right? That's what I'm trying to figure out. Okay. Step 2, what we're going to do is take a look at our chart, okay? Instead of going from the top column or the top row to the bottom row, we're actually going backwards. So we're looking at the bottom row and we're trying to figure out what the top row is. Now, it might be a little bit weird to look at because we have a negative value, but what do you think the denominator of the angle theta is going to be if the tangent is the square root of 3? Yeah, it's going to be something over 3, right? So looking at my chart, I know the angle. I know this is going to be something pi over 3, right? I know it's got to look like that because, well, the chart kind of tells me what the denominator is going to be. Okay. Then what you're going to do is you're going to take a look at your unit circle. Okay. You're going to look at all of the angles on the unit circle that are over 3. And you also want the angle to have the tangent be, in this case, negative. Okay. So let's go through that systematically. Okay. I know that the answer is negative square root of 3. Where is the tangent negative? So which quadrants are tangent negative? Do you remember? It's actually just two quadrants. 2 and 4, right? Right, so remember that phrase that we had? It was like all students take calculus or something. Everything is positive in quadrant 1. Only sine is positive in quadrants 2. Oh, looks like I got it wrong, didn't I? No, wait, nope, we're good, we're good. Tangent's positive in quadrant 3, and cosine's the only thing that's positive in quadrant 4. So that's how we're getting that tangent is only negative in quadrants 2 and quadrants 4. Does that kind of make sense? Okay. Now let's find all the angles in quadrants 2 and quadrants 4 that are over 3. Okay, so which 2 angles in quadrant 2 and 4 are over 3? well, if I look in quadrant 2, it looks like 2 pi over 3 is in quadrant 2, right? So that's in quadrant 2. And then if you take a look at quadrants 4, 5 pi over 3 is in quadrants 4. Okay. So I basically looked at my chart to figure out what the angle is going to be over. I know that tangent's negative in quadrants 2 and 4. So I just took my angles that are in quadrants 2 and 4 that are over 3. Does that kind of make sense? Okay. Let's go to step 3. Step 3 says that my angle has to be in quadrant 4. Okay. Oh gosh, quadrants 1 or quadrant 4, right? So I need to take the fact that tangent or inverse tangent can only be in quadrants 1 or quadrants 4. Well, which one of the two angles is in either quadrants 1 or quadrants 4? Yeah, 5 pi over 3, right? 5 pi over 3 is the one that I literally labeled is in quadrants 4. So 5 pi over 3 is the one that's right? Now, if you don't have to write out all these steps. I know I'm kind of going through this in a very systematic way. If you want to skip, if you kind of want to merge step 2 and step 3 together, that's fine. This is just how I go about thinking about this. Okay, so this is how I think about my answer. If you can do this faster, then go ahead. Finally, going on to step 4, I know that 5 pi over 3 is like 1.6 pi. Is 1.6 pi between negative 0.5 pi and positive 0.5 pi? No, right? 5 pi over 3 is bigger than pi over 2. So what I'm going to do is I'm going to subtract off 2 pi. Okay, so I have 5 pi over 3. My common denominator is over 3. 2 pi as a fraction over 3 has to be 6 pi. And I'm going to get negative pi over 3. And that's my final answer. Okay. I know that some of you can do this in your head, and that's totally fine. If you can do this in your head, go ahead and do it. This is how I go about thinking about tangent questions. I know it sounds a little bit, it sounds like a lot, but it's not too bad. Okay, why don't we do example 8 together, and then I'll let you on your own. Okay, example 8 tells us to find the tangent of -1. Okay, actually, you know what? I'm going to do example 9. I'm going to let you do example 8 on your own. Let's flip over to example 9. I'm a little bit scattered today. Okay, so this time I want to find the inverse tangent of square root of 3 over 3. If I want to find this, step 1 is asking myself, what angle can I take the tangent of and get the positive root 3 over 3? Okay, so I'm trying to figure out what that is. Now, taking a look at your unit circle right now is not going to help you because tangent's kind of hard to figure out given an endpoint. So what I would do is look at your chart. Okay, what's going to be the denominator of my angle this time? 6, right? Because, well, root 3 over 3 is here. Pi over 6 has to be what my angle looks like. Okay, so my angle has to be over 6. Okay, so I'm looking at something over 6. Okay, this time the tangent is positive. Where is tangent positive on the unit circle? Perfect, right? Wait, is it 4? I think it's 3, right? Yeah. Okay, so remember our unit circle. I know that everything is positive in quadrant 1, so tangent has to be positive in quadrant 1. Okay, sine is the only thing positive in quadrant 2, so tangent's not positive there. Tangent's positive in quadrant 3, so quadrant 3 is where tangent's positive. And then cosine's the only thing positive in quadrant 4, so we're going to leave that one alone. Okay, let's find all the angles in quadrants 1 and 3 that are over 6. Okay, so this is still in step number 2. Let's see, in quadrant 1, what's the angle over 6? Good, pi over 6. And then in quadrant 3, what's the angle over 6? 7 pi over 6, right? Now, if you don't want to write this out, that's fine, but I like to do this, okay? Now, let's go to step 3. Now, step 3, we want to figure out where the inverse tangent actually is. Inverse tangent can only have the answers between, so it can only be in either quadrants 1 or quadrants 4, right? So what's my answer here? Pi over 6, right? Because pi over 6 is the one in quadrant 1. So pi over 6 has to be my angle here. Okay. Going on to step 4, I know that my angle has to be between negative 0.5 pi and positive 0.5 pi. Is 1 over 6 pi, is that between the two angles that I like? Yeah, right? Isn't pi over 6, that's like what, 0.6 pi? Gosh, no, that's not right. What's 1 over 6? 0.2? I think pi over 6, gosh, what is 1 over 6? This is really embarrassing. I should be better at math than this. Let's just pretend it's 0.2, okay? Is it 0.1? Oh, goodness. Okay, well, I rounded it correctly. Yay. Okay, I am very bad at arithmetic. That's kind of embarrassing, but pi over 6 is 0.2 pi, right? That's definitely between negative 0.5 pi and positive 0.5 pi. So I actually don't have to do anything to pi over 6 to make it in between those two numbers. So my final answer really is pi over 6. And that's it. All right. Now I know some of you can do this in your head. That's totally fine. If you can do it in your head, just go ahead and do it in your head. But I like to write out all my steps to figure out, okay, what's my thought process here? All right, why don't we come up to the front? It looks like everyone was on a good track as I was walking around. I do think tangent is kind of the trickiest one of all of these because you have to think about negatives and positives all the time. But let's go through example 8 real quick. Yes, do you want to go over how you did? Oh, no, it wasn't Yes, it was Allison. Do you want to go over how you did example 8?
So, for step 1, you would be tan equals -1. And so using the chart, that would be something pi over 4. So then I found the angles in the quadrants 2 and 4 because it was negative. And 7 pi over 4 is the only one because it's also in quadrant 4. And then I subtracted 2 pi from 7 pi over 4, negative pi.
Perfect. Any questions on example number 8? All right, let's go over to example number 9. This one was a little bit different because it's not like a actual, it looks like we only have a couple options here. Yes, do you want to take us through this one?
And so I rewrote it as what angle of tan would equal 0. And I looked back at the table to see like what would be the corresponding denominator, but there was only one answer, 0.
Perfect, right? 0 is the only place where tangent equals 0. It actually also equals 0 at pi, but pi is in a different set of quadrants. We don't care about that. So 0 is totally fine with me. Any questions on example 9? All right, before we finish this up, I do want to talk about a little shortcut of what we can do here. So let's kind of just piece together all the information that we found so far. In example 7, we found that the inverse tan of negative square root of 3, we said that was negative pi over 3. Okay. Now, in example 8, we did the inverse tan of negative 1, and we said that was, gosh, negative pi over 4. Okay. In example 9, we did the inverse tangent of positive root 3 over 3, and we got pi over 6. Okay. Now, I know we didn't do a lot of inverse tangent questions, but let's just see if we can see a pattern here. Okay. Let's see. Now I do like doing all the steps just to show that like we understand where inverse tangent is coming from. But a lot of the times we want to do this a little bit faster than doing all the steps. Okay. Now let's see. When we're trying to find the inverse tan of a negative number, it looks like the angle is always going to be negative. And that kind of makes sense because it can't be in quadrant 1. Quadrant 4, the tangent's always going to be negative. So if we ever want to find the inverse tangent of a negative number, the angle is always going to be a negative number, right? Now, positive numbers, the angle is always going to be positive, okay? Now, if you kind of take a look at what the answer is, do you think we're ever going to get something that's not like 1 pi over a number? Not exactly, right? Because if you take a look at quadrant 4, the angle is always going to be like negative pi over 3, negative pi over 6. We're never going to get something like negative 7 pi over 11, right? Same thing with quadrant 1. Okay, so if you want to do a little cheat to do this a little bit faster here, one thing that you can think about is, well, if I know that the denominator is going to be the same, so I know that the angle is going to be the angle in this chart. If you're finding the tangent of a negative angle, just put a negative sign in front of it. Okay, does that kind of make sense? Okay, so why don't we do a quick one here? Let's say I wanted to find the inverse tan of, I don't know, just 1. Very quickly, what's the answer to that? Take a look at your chart. Pi over 4, perfect. So you just take a look at the chart, right? And it's positive, so it's just a positive pi over 4. Very quickly, what's the inverse tangent of negative root 3 over 3? Good, negative pi over 6, right? So just take a look at your chart. That's the angle. If it's negative, stick a negative sign in front of it. If it's positive, just keep it positive. All right. Any questions on doing the inverse tangent? Okay, now I know it seems counterintuitive that I told you the long way to do it when there's an easier way. I think the long way brings a better understanding of what we're doing when we do inverse tan, instead of just learning stick a negative sign or keep it positive. But this is a little bit faster. All right. Any questions on inverse, trig functions, anything like that? Alrighty, then what we're gonna do now is I am gonna pass out a new set of guided notes. I do wanna get this out of my hands, honestly. So we're gonna talk about this a little bit, but yeah, let's keep going. All right, I know this looks scary, but it is the last thing on our final. So let's what we're gonna do is we're actually gonna combine inverse trig together now, okay? So if you ever go into a calculus class, this is something that you're gonna see a lot because composition of functions is very common in calculus where we stick one function inside of another. Okay, so let's just see what happens when we combine these functions together, when we kind of compose one inside of another. So here we have an example. Okay, here we want to find the sine of the inverse tangent of the square root of 3. And by the way, there should be another parenthesis sign here. If you saw this on like a test or something, what do you think you would try to do first? Yeah, do the inverse tangent first because that's on the inside. And then after that, you're going to do the sine, right? So basically what we're doing is we're doing inverse trig, but we're doing it twice, okay? So remember when we do order of operations, we kind of like work on the inside and kind of work our way outside. Oh, hi, Amara. Okay, so let's just work on the inside and then kind of work our way outside. So first, let's just do the inverse tangent of the square root of 3. Okay. Now, we can do the full way of doing it, but there is the shortcut, right? Let's just do the shortcut because I'm lazy. Okay, gosh, looking at your chart, what should be the angle if I'm trying to find what angle tangent comes out to be the square root of 3? Pi over 3. Okay, and should it be positive or negative? Positive, right? Because, well, if I'm trying to find the square root of 3, it's got to be a positive pi over 3. Okay, so I know that the inverse tangent of the square root of 3 is pi over 3. That wasn't too bad. Okay, next, I know that the tangent of the inverse tangent of the square root of 3 is pi over 3. So I know that this whole thing really is pi over 3. So now this question becomes, what's the sine of, well, pi over 3? Okay. Now remember, sine is the y value. So what is the y value when the angle is pi over 3? Perfect. The square root of 3 over 2. And that's it. So, oh, did not mean to erase there. There we go. So all you have to do is do the inverse tan, then do the sine, and we've got our answer. All right. Any questions on this example here? All right, why don't we do another one? Actually, you know what I want to do? There is something I want to do at the end of class today. So why don't we kind of end class here? Okay, and there is something, an order of business I do have to do here. Okay. So have you heard about course evaluations? Yeah, most most of your classes are online, right? So you have to go on Volnet and do it. The math department's really not that great with online stuff, so it's actually on paper. So I actually have to ask you to fill out a course evaluation on paper.